We have engineer Surya Prakash with us. So, sir is engineer consultant mentor. He is eminent engineer consultant mentor who has made significant contribution in civil engineering. He did his BTech in civil engineering from JNT UK and then masters in structures from IIT Madras. And he worked as a design engineer and then established Satyavani Projects and Consultants Private Limited in around 1994. He's also founder and mentor of Smart Infra EST, which is a trust dedicated to the civil engineering to enhance the employability and employment. He was president of ACCEI in 2013-15 and is founding president of PSIS in 2013. Sir is FIE, FACCI, MICE, etc., etc., etc. So I'm just making it short so that we can focus more on the technical part of it. So today, sir will be speaking on planning aspects of precast concrete construction as a solution to delivering larger scale projects. So over to you, sir. You can start sharing your slides.
Thank you for a great introduction. And now I'll be sharing my presentation. Good evening to all the delegates, engineers from across the country, and good evening, Vinay Gupta ji, President ICI, and all the organizers from Pune, President of ICI Pune, and organizing secretary of this SEMCON. In fact, I am somehow connected with SEMCON many times in Pune. Live, I made presentations in Pune, and thanks for considering me in this interesting topic today. And so the very topic of close to my heart is planning aspects of precast concrete construction as a solution to delivering large scale projects, which we are dealing right now. Introduction to precast concrete construction. And we'll be talking about precast technologies and elements, about the elements, and the 3D volumetric construction in precast, and the 2D to 3D volumetric construction also. And the planning aspects of precast concrete construction, delivery of large scale projects, and general precast in buildings for residential, commercial, warehouse, institutional, and parking garages. So these are the topics I'll be covering today. And majorly, we all know recast. Why we prefer is because of the hindrance that happens in the projects when we do in situ construction, and climatic conditions like very cold or very hot conditions that can happen in the project site, and also the constraints at the site, which will require crash schedules and parallel activities required in construction, like while excavation is happening, we make the structure and mechanize the construction activity and enhance durability of the structures. Also, I have chosen precast because of the better quality and reduced carbonation in concrete, and the risk mitigation like skill, labor constraints, and also cost constraints, because escalation in cost is bound to happen when we do large scale projects because of the sudden spot in the demand for the material. So through this precast, we can have fixed cost delivery of the project and enhanced quality and better safety management and delivery, assured delivery. So these are all the reasons why we have to choose precast in building construction. The proposed structure is split into simpler segments produced as individual units and assembled in position to form the structure, as we can see here. And we can divide the entire structure into handleable size of the elements and also weight of the elements and assemble them at the site. And joints, though, is perceived as a challenge, but any structural engineer can handle these joints who are conversant with the precast construction methodologies and available materials for the joints. And we can see the advantages of quality, the conventional versus precast, what I'm showing here, and also saving the time with the reduced number of activities, like no plastering, no scaffolding required. Once we erect, we can straight away go for fixing of the joinery, doing the flooring and painting directly. And dimensional accuracy and a perfect finish, which will give the aesthetic look and better appearance of the facades, and a permanent finish. We all know when we go for plaster or rendering, we know that there will be falling of the plaster and cracks in the plaster, all that. But once we produce in the controlled environment, we have the concrete finish itself for the final facade, then you don't have all these problems and we have the permanent finish. And it is eco-friendly and lesser labor dependence compared to conventional construction that we do, and lesser pollution on site, definitely. No dust. In Delhi, we see every winter commencing, we all know that the construction is stopped because of the pollution that they expect. But with the precast, we can handle it, maneuver it very easily. So the methods of implementation that today we focus on, we should be aware when we plan for the construction, what are all the technologies available for producing various types of elements like columns, light wall panels, structural wall panels, and double T's and single T's, which are normally used for larger spans, inverted T-beams, hollow core slabs, spandrels for the edge beams and the facade, and rectangular beam stairs, which is very advantageous, particularly in stairs. We know it is very difficult to handle the accuracy of the tread and rise that is designed. With the precast, we can straight away go for adhesive and the tiles or the stone fixing very easily and maintain the accurate tread and rise in the dimensions in the precast stairs. So this is one of the multi-level car parks which we can see with the spandrel columns and corner cores for elevators and staircase. And it will be very effective utilization of the space, including the ramps for parking, to be utilized for parking. And we can also use many types of precast structures, like anything that is required, we can convert into precasting. Primarily, we are changing concreting from in situ to offsite casting and then assembling at the site. And we can see all the large span structures, various shapes of the beams and slabs that can be done. And a residential construction with the large panel, precast panels, whether it is walls or slabs, we can thereby reduce the number of joints in the structure also. And the joints that are hybrid, like we have the precast panel, we have the precast wall, precast slab, but the joint is in situ. This is most prevalent in UK, Middle East, and India. That can ensure the rigidity of the joint and then also the performance of the joints. So this is a battery mold type of casting of the walls where we need form finish on both the sides of the wall. Normally we have this tilting table method of casting walls, which is cheaper in cost, but you will get the trowel finish on one side and form finish on the other side. So battery mold is a technology that is developed in the last 10 years and which is being used in many of the projects, which is very advantageous in terms of eliminating any plaster being required on the trowel finish side, because both the sides are form finished. And the extruded type of panel like hollow core and slip formed type of panels for the slabs, you can see the difference. And normally these extruded ones will have almost very less steel, that too used only for pre-tensioning in the panels, hollow core. So finally, the planning and design, we have to, as engineers, right from the conception of the project, we have to consider this method of technology depending on the time available and the size of project to be delivered. For example, I get a client who is asking me to deliver a project within 1 year to build about 10,000 houses or 20,000 houses. I have to complete in 12 months. Then I have no other option but to choose this precast, because I can eliminate all the uncertainties in delivery and also the assurance of the delivery time, with the quality not being sacrificed. We have to draft the design intent and prepare the design basis based on this precast only. And right now we have only handbook prepared by ICI in India and also some of the IS codes which can be used and interpreted for precast. But for the design, you can use US Precast Concrete Institute manual, PCI manual. And as introduced, I founded the Engineering Structure Society of India in India. And we are also trying to work on bringing out a document on precast concrete construction. And loading structural systems, transportation, handling joints to be kept in mind while drafting the design intent and doing the planning. That means right from the initial framing plans that we prepare, we have to consider the type of construction that we are going to propose so that we will be able to deliver in time that is available. And the general arrangement drawings, erection plans, shop drawings to be prepared by the consultant and to be utilized in production for the precast elements. Stripping, stacking, transport, handling stresses to be considered in design of these elements. And these are all available in PCI code readily. And analysis, mainly in the analysis, the most important point that we have to keep in mind is the robustness. We have to do the gradual collapse of the structure and consider the critical elements to fail and then still ensure the stability of the structure, because we had some bad incidents in precast earlier in India where they are constructed without considering this robustness, and also the checking the joints for the all the loading conditions like seismic and wind loads in case of high-rise structure. Construction loads and erection loads to be considered, and element design, joint design to be very clearly taken care, and stringent quality, reduced tolerances, and reduced partial safety factors which can come in future codes. Like as you're all aware, we use the same partial safety factor whether we are doing precast, whether we are using the best construction company, or whether we are using the very bad contractors or very bad construction practices. But with this precast, if you do the uncertainty analysis, and we can save on the partial safety factors and design, which is bound to happen in future, if not immediately, maybe in a decade or so. So this will help in saving on the materials in precast when we use this uncertainty factors by using fuzzy logic. So the modular precast concrete elements for the buildings, I'm showing some of the sample detailing that we do, the level of detailing that goes into the precast which is required. You can also see the stripping and the stacking and the handling stresses that we do, and we show in the drawing itself, so that in the casting and the handling they use the same method of casting, stacking, stripping, and transport. And these are all the bar detailing, which will almost go into the 1:1 scale to check the facings and clearances in the joints and reinforcement. This is the typical detail of a double T, and these are the details of the end bearing parts of these double Ts which we have done. And we can even do the precasting of portal frames like this. This is a real executed drawing, and you can see the handling, stripping, stacking, and handling, how we have detailed, and we consider all the CGs of mass and stiffness, and then give this drawing. And this is a hollow core drawing, and these are inverted T-beams, and this is the detailing of an inverted T-beam, and the structural wall panels, and the spandrels, the edge beams, and the stair. In stair, you can see how we have given this stripping and stacking and transportation, handling of this stairs. They're all shown in the drawing. And the structural systems, actually, we have many types of structural systems, framings we can do in precast, starting with the hollow core and intermediate floors. And then medium rise buildings, we go for skeletal normal frame systems. And high-rise buildings also, we can go with skeletal systems. At least I'm aware of 40 to 50-story buildings being done in precast. And precast structural systems with portal frame systems, skeletal structures, wall frame structures, and floor and roof systems, and facades. Facade alone can be precast also, like you can see in this drawing. And load-bearing precast walls, which is very common nowadays in residential construction, which is very advantageous because we can prefix the plumbing, electrical requirements in the walls and erect very conveniently. And we purposefully increase the spans to increase the speed of construction by using hollow core, because hollow core is advantageous in using for minimum of 6 meter spans. And otherwise, if we don't want to go for it, save cost on it, we can also go for large panel slab and large panel wall construction and have the joints only between the slab and wall. It's quite common in even in regular conventional construction. You have the joints between the roof and columns or beams. And we can also have single portal frames precast with a rigid joint, and large span open spaces inside the building is possible by using large span beams up to 50-meter spans. And we can also have typical column beam junctions like this. This is a dry joint with a welded joint between the beams and column, and beams and double T's. You can see the steel plates that are there in this picture. Next, the recent developments is waffle crete panels that can be used for in low-cost construction, where you can also have the larger panel with the lesser thickness of the concrete. And there are readily available vendors actually who can supply these waffle crete steps. So this is how restroom facilities that can be developed with the waffle crete technology and a wall panel. Next, ICI handbook, as I mentioned, I really appreciate ICI for bringing out this handbook almost like 9 years back itself. Next is the casting, stacking, transport, and the erection. So casting, like any conventional, but off the site, we'll be doing the casting by tying the reinforcement and handling hooks and wall panel stacking. You can see here, and the handling hooks for lifting and handling. And then this is the stacking of the beams that we do, and the handling of the slabs or wall panels that can be done. And there are all the panels and the transportation of the panels. We need the large trailers. Why I'm showing all this is when we consider the precast, we have to also consider the accessibility to the site and the clearance of the site without power lines or distribution line and all. We have to keep in mind how a trailer can reach the site and how a crane can lift and erect these panels. Maneuverability of these large panels. Here you can see how much open space is available. So this is also important to have enough open space around the building. For example, this 1 lakh square feet building is completed in a month's time. And even in India, we have many examples of shopping malls of 2 lakh square feet being completed in 2 months' time. So these are also some of the junction details and multi-level parking garages. And these are some of the demolding of the wall panels, which is the simplest technology. We can even set up this casting of the wall panels at the site itself, depending on the time availability and number of panels to be cast every day. And transportation of the panels and erection of the panels. And this is the precast wall panel erection typical photograph. And this is the partial slab forms where we can do the partial precast and partial in situ with the solid wall slab panel also. And precast staircases and precast wall panels and column and beam precast with the joints. And this is the wall panel casting typical photograph and the hollow core panel erection you can see. And this is the aesthetic finish. We have acid finish and a texture finish, and this kind of aesthetic treatment of the windows also is possible. And this is the precast wall panels photographs and foundations. Also, precast can be done. It is done in Tamil Nadu in one of the housing projects. And dowels for the wall panels. This is interface between the cast in situ wall and precast wall. And precast wall panels erection. This is one of the project we did in low-cost housing up to 11 floors. We have completed 4 towers of about 2.5 lakh square feet in 4 months' time, finished and handed over. From the date of handing over the site, we handed over the towers, 4 towers of about 2.5 lakh square feet in 4 months. So that is why I always say for delivery, the precast is a very viable solution. And we completed 4,000 units in a combination of precast, and conventional within 12 months without escalation in the cost and at a cost of 1,280 rupees per square feet. So these are all some of these photographs, stacking of the wall panel, handling of the wall panels, transportation, and erection. And this is how we start planning. We do the unit plan. We try to bring in the repeatability of these wall panels and the slab panels, and we develop these different sizes into block, and we also develop these blocks into combining MIG and make a layout like this. This is the we develop this keeping precast in mind so that the modularity and repeatability is kept and maintained. And this is another option of same blocks being used, but in a different aesthetic layout that we have done. And we are working on many projects across the country on this mass housing, where this is one of them which we completed actually. So here you can see the blue color blocks are all precast, and this green color is my one, and the gray color, brown color is all conventional. So in the same project, we have implemented three technologies and could deliver in time without affecting the cost, but with a good quality in construction, even in low cost. So these are all some of the photographs of these during construction and after completion also. And in infrastructure also, we happen to work on a metro project in Gurugram where we use this precast I-beams in station buildings and had gone for a very elaborate detailing, and we could deliver the quality. And the school buildings also, and some of the machine availability and profilers that we use in precast are slip formers and extruders and profilers. And the batching plant, which is common, we all know, only the mixed design has to be considered, considering the, for example, for hollow core, we need a concrete with a water cement ratio of 0.2 to as low as 0.2. And the UOT cranes will be required, and the stacking, handling the A-frame cranes and all that. And these are all the precast wall panels, that is casting yard for the wall panel, and the batching plant, and the casting, and the preparation of the mold and reinforcement and tying, placing of these various services also is done, and concreting and finally stripping, lifting, and this is the concept of commercial. Like this is what we prepared as a 3D view, and this is what we deliver. And this is the completed project. You cannot make out the difference between precast, my one, and all three are there in this photograph. So that is the advantage of using the technology for assuring the delivery of the product. And this is the photograph before completion. And another project of commercial industrial flatted industry that we have done, and with the 12-meter spans, with the 5-storied industrial floor, which we have done and completed. And this is during construction photograph. And another office building that we have done in Vijayawada, a 2 lakh square feet, again completed in 6 months time. And this is the photograph inside. You can get the quality of it. And the entire feeling will change actually with the quality of the finish that we get with the precast. This is another CRDA office building that we have done in Vijayawada. And Secretariat, interim government complex in AP also, we have used the precast beams. And we are right now doing an institutional building, completely in precast, with the brick wall finish that is nearing completion for handing over. And now I'm coming to the main important point today I wanted to cover, which we are implementing right now, is the 3D volumetric modular construction with a half-day cycle of production. That means with the same mold, I can produce 2 houses in a day with one mold. That means if I have one mold, I can produce 600 houses in a year. That kind of speed in delivery, which is possible. And we will be setting up the project-specific plants, and we have the mold manufacturers in India itself, and the 3-layered vendors. We have mold supplier, we have the production contractor, that is precast production contractor, and general contractors. who will be assembling and who will be developing the external services and all. So delivery of 4,000 DUs per annum minimum, if you have, this technology will help a lot. And so this is the plant setup that we get. That is the mold for casting of the entire module of a house. Then this is how the stripping will be done, collapsible internal form, and then we'll be having, this is the reinforcement being tied, and we have the slab below. And we will be lifting the inner mold like this, and after casting, we have different technologies again in 3D volumetric itself. And so this is the demolding and lifting of the module, and then checking quality before dispatching. And this is the entire unit of the EWS housing, you can say, or we can also make the units into 2-3 mods like this, even a bigger houses. And erection of these 3D volumetric boxes into a house like this. So this is the planning that we are doing for production of the houses and delivery of the houses to the tune of 4,000 houses in a year. Next is 2D to 3D. That means we cast 2D large construction. The assembling of the unit is done in the plant itself, and we transport the 3D house. This is already happening in India. We have vendors in Bangalore, we have vendors in Coimbatore, and already some projects are completed from 2D to 3D method, and transport and erection of pre-assembled models. So this is about what I wanted to share. We are working on this delivery of these projects with the complete precast. And I thank Simcon for giving me this opportunity, and ICI for allowing me to share this knowledge. And probably we can open the house for questions.
Yeah, thank you, sir, for extensive and detailed presentations. We have a lot of questions, so I'll just try to combine and I'll take few questions now. So we have questions from two people about the joints. So I'll just combine them. So they would like to understand. So it is from Mr. Desai. So he's would like to ask about how the joints are made rigid in precast construction. And there's another question from Mr. Ashwin. So he's also asking about how the results of for leakages in the structure for precast residential building, how the joint sealing is done. So rigidity and the sealing, joint sealing.
Actually, we have many methods of detailing for the joints. I mean, I can share those details if somebody is interested. I will share my phone number and mail ID. But I would like to quickly tell you, even in our conventional construction, we have a core joint between the beam and column, for example. So what is happening is the reinforcement that is required is going into that. The difference between precast and conventional is in precast, we have two different elements, and we are having what we call loops that we have in both the elements, and will be grouting the non-shrink grout into these joints to make the joint capable of taking the forces, whether it is shear or flexible stresses. There are many methods of joint detailing. I have a separate presentation for joint detailing itself. So I can share that and details depending on the case people are planning to construct.
How to take care of the leakage so that there should not be any leakages.
Actually, leakage is a result of bad detailing and the bad quality anytime, whether it is precast or cast in situ. So it is always good to have good detailing practices. We have buildings where we don't have leakages at all, where the detailing care is taken.
Yeah, right. Totally agree, sir. So we have another question from Milan. So he's asking, is it possible to fix household amenities on the wall? Like, what about the plumbing and electrification work? Is it concealed or outside?
Yeah, we have concealed only electrical and plumbing. We have done, everything is we use the flexible PPR pipes so that at the joints also we can connect these plumbing lines or electrical conduits.
So can you just let the audience know the IS codes used for precast construction?
Starts with the 4000 series actually. We have a
Okay.
precast concrete code, but
Mhm.
it's not updated with the latest technology. And any code has to start with a manual or handbook, which ICA has initiated actually. So
Yeah.
we can all work as a fraternity and further take into the codal form.
So we have another question from Professor Deepak MD. So he's asking what are testing methods for ensuring quality post erection of precast panels?
Yeah, main like drawings, we have to do the testing, and whatever when we have multiple repetitions, like 100, more than 100 repetitions, as per the code itself, we have to do one prototype test. And the elements, we do the testing as a rule, like slab panels, wall panel, individual panels, we do the testing. And for the joints, we have to do the prototype test.
One last question. So is it sustainable in high seismic zone or how the seismic zones are to be considered in the designing phase?
Yeah, for example, US, California is the state with the highest seismic activity, but there also precast is done. And in India also, we are working in northern India and all. And we will consider all the seismic provisions while design.
Thank you, sir, for your detailed presentation. Our another sponsor, Sika, here with us. So I would request the team Sika to come on the dais and request them to present their products and services.
This side Sachin Musale from Sika India. I look after the specification part for South Zone and West Zone. So I'll be just presenting on company profile for Sika. So we are Sika. So as you know, everybody is knowing about Sika construction. We are into a specialty chemicals, company with a leading position in development and production of systems. So Sika at a glance, globally we have got 25,000 employees. We have got a presence in more than 100 countries. We have got plants, more than 300 plants across the globe. Last year we have started new plants and expansion for the 6 plants. We have got patented for 83 products in 2020. We also acquired company last year. One company we have acquired, and recently we have also acquired a big company, that is MBCC, in 2021. Last year turnover is around 7.88 billion CHF. It's closely around 60,000 crores in Indian rupees. So this is about the Sika India, Sika. So we have markets like concrete. We have got a presence in concrete. We have got a market like waterproofing, roofing, building finishing, flooring and coating, sealing and bonding, refurbishment, and industry. So we have got this market. So we have got the opportunity from Simcon to talk on the grouts products, especially for the precast buildings and for the sealants. So we'll have a brief discussion on the grouts and the sealants later by this presentation. I'll just play a small video for your understanding. Thank you. That's it from our side.